Hello, everybody, and welcome to today's session, the benefits of CI/CD approach in DevOps. Thank you for taking some time during your lunch or evening break, where you are located currently, and being here today. This is our second intake webinar. We are taking your valuable feedback into account and hope to improve the experience for everyone, as it's hard to make content that's suitable for all uh, publics. Denis is our lead DevOps engineer at Naulis, who is already working longer in the field. Is already working in the field when I was still in kindergarten. So the content of the webinar was built with practical expertise in CI/CD of Thomas Veicht and Simon Vleugels. We will mainly cover the complete lifecycle and flow of CI/CD process using the infinity symbol as the backbone during the presentation. At the end, you will have a helicopter view of the whole process and understand the benefits of CI/CD systems. There will be a live Q&A section at the end of the presentation. You can post your questions in advance in Zoom by clicking on the Q&A icon at the bottom middle of the Zoom application. The recording of the webinar will be available in a few days after this presentation is done. So for the people that are just joining now, I see there are some new attendees. Denis will take over from here and explain the benefits of CI/CD in development. So that's it for me, and I will give the word now to Denis.
Thanks, Max. Thanks for the nice introduction. And no, I'm not that old. I think you were already at school when I did start working. So let's share my screen and go directly to the presentation of today. So as Max mentioned, we are here to discuss about the benefits of CI/CD approach, especially in DevOps. So what we will cover is a number of topics. So first, starting with a definition of what is CI/CD. Then we'll explain the benefits while explaining the concepts. We also walk through some practical examples before finishing with the conclusion with the main facts and the main aspects. So what is CI/CD? First, some definitions. CI stands for continuous integration. That is a software engineering term which refers to the practice of merging developer work into a common repository. This on a regular basis. So typically could merge several times a day, and continuous integration is meant to help that. CD, continuous deployment. This term refers to the practice of releasing software in short cycles. So again, instead of having cycles of weeks, months, the goal here is to, with the help of a CD system, to reduce that. Could be up to several times a day eventually. The context. So where do we use that? We typically use CI/CD in software development, being embedded desktop, web, or mobile applications. It is not really suitable for other type of products. Well, anything with physical parts is a bit more difficult to a bit less practical for CI/CD systems. So electronics and mechanics are out of the scope. And basically, CI/CD is the backbone for DevOps and Agile way of working. It is there to support the activities and make them efficient. The purpose of CI/CD is to bridge the gap between development and operation teams. And it is doing so by enforcing automation in all the steps which can be automated. So building, testing, deploying, and so on. Typically, if you are a software developer, there are tasks that you repeat over and over. You code, you compile, you test, commit, push, merge, and you do that all the time. When ready, operations team can take your work, your software release, and configure it and deploy it. That can become quite tedious for large code bases and big teams. Typically, you would have merge issues. You will have less time eventually to test, so you will reduce the amount of tests, eventually also delay the releases. Ultimately, you may have incorrect deployment. So a lot of issues which luckily a CI system can help to solve. Maybe to explain a bit more on the traditional way of working. Here in this example, we see there are different developers. They each work on their features and I would say on their side. They have a limited, typically they would have a limited view on what others are doing because they work, they change, and the merge happen only after everything is ready. And those merge times can be really difficult with a lot of potentially a lot of discussions and rework because of conflicts, because of new issues popping up. Of course, this can be mitigated by having a quality officer role. However, this kind of role requires high level of expertise. We need to have a good overview of well, the software, the way of working, and yeah, try and anticipate or reduce the amount of issues. But in the end, the quality is less certain. You have testing, but it's typically taking place late in the process. Yeah, before the release, obviously, but yeah, really not early. And that is a difference, a big difference with the CI/CD way. Here in this view, you can see that well, we have the same amount of developers. They also work on their features, but they push and merge more often. And they can do so because the CI system automates the build and the test. Um, Issues are detected early in the process. We don't wait right before the merge and release, but in this case, as early as possible. And therefore, as everyone is responsible for correct integration, then communication is encouraged. Developers talk to each other. They can also work with in pairs to, I would say, program a feature, develop a feature, and they also can use they can benefit from a better way to communicate with yeah, documentation tools, with chat and other conferencing tools. To illustrate even further on the agile and DevOps way of working, um, here in this picture on the top left, you can see that yeah, you have your agile development with sprints, meetings, and so on. And CI, a CI/CD system is there to support for first the continuous integration where people commit, push, merge, and the system takes it to actually build and perform some testing. Then those, yeah, the software which has been built can be promoted for testing, where you can have more functional tests or smoke testing on target if this is for an embedded device, or integration test for any type of application. And the system, the CI system is doing it for you. And when done, the code can even again be promoted for delivery. In this case, delivery could be for your end customers. It could also be for a QA team for further validation and acceptance testing. And in all those steps, there is feedback that can be fed through the development team so that, well, issues can be added to the backlog, and the next sprints can include fixing of these, or even react more immediately. And that is then when using a CI/CD, good CI/CD automation, that becomes an extremely efficient way of working because of the really fast and continuous feedback that you get on a different stage of development. So again, some summary of the use cases. So what can be done? Automation of recurring tasks with low added value for human. So of course, everyone can build, test, and so on. But if a machine can do it, that's time that you save to do something else. So well, having different steps supported by a tool definitely helps to be more efficient. In this overview, we see a lot of topics, so we will not talk about each of them in detail today, but this is to give you a view on the workflow and automation which can take place with a good CI/CD system. You can see here the infinity symbol that Max was referring to at the beginning. And in each of these steps, you have different tools which can support the automation and everything. Speaking of CI/CD, there are a lot of tools. A lot of tools exist. Various tools with different level of integration. So here you can see at the center the popular tool Jenkins. You have also some other solutions, Drone, Bamboo. You have also some integrated solutions such as GitLab and Azure DevOps, which we will detail a bit further in the concepts in the next slides. So the concepts, speaking about CI/CD, the first thing to know is that it covers all the steps of development. It's not just for building and testing, but it can cover it all. And the steps which are more important, of course, we will detail in the walkthrough. But it's really important to keep in mind that it can cover all and support all in your development. And one first concept here that is important for CI/CD systems is the architecture. The base principle is to use a distributed architecture where we would have a server with a web UI. This server will we will perform different tasks for checking access, also scheduling jobs, providing useful information to users. And then next to those, to this server, we have a number of runners. So runners which would execute the jobs, build, test, deploy. Having those runners separate allow then well, to load them fully and still keeping the interface reactive, meaning that well, we would still be able to check the status with the web interface and well, at the same time having maximum speed for the jobs. Typically, Linux is used for the server and the runners, but we can also mix it with Windows and Mac OS. For example, when there are specific tools related to the operating system, which are needed for your pipeline. Another concept is the integration with version control. So any modern version control system can be used. As long as they have good branching and merging support, well, the CI/CD system will work efficiently. It is better to use a distributed version control, such as Git or Mercurial, because they offer more flexibility and possibilities. And yeah, some solutions such as GitLab and Azure DevOps, they only support Git repositories. So it's of course a very popular tool, but this also drives the decision in selecting the correct tool. Here's an example with Git. This picture shows you the different branches. So from left to right, you have feature branches in which developers work and commit their changes. They are then merge request performed, and the result is going to the develop branch. When enough work is collected there, the code can be promoted to a release branch and eventually also get some hotfix, the result of hotfixes. And in the end, having a master branch for production with tagged versions can be done. The nice thing here is that with a CI system, each operation that is performed can trigger a pipeline, and so you can verify your work all the way. Speaking of pipeline, here's an example, is an example of what can be done in a CI/CD pipeline. So you have different stages. You have build, test, review, prod, cleanup. You of course can customize it, but here what's important to see is that for some steps, like for testing, you can also have things done in parallel, meaning that yeah, you can maximize the efficiency and the timing of your pipeline. And each and every step here can also get a with the web UI can get a clear and quite easy to read overview. Another concept for CI/CD systems is the triggering and notification. As I mentioned, there are several events which can be used to trigger operations. So, for example, push or tag that we can detect and trigger a pipeline execution. Another event is when the pipeline is completed, we can notify the team with emails or chat messages, and then we can inform about failure or success. And so a CI system can react on those events and can automate the workflow of information to inform the team and have a good overview on what's going on. Another concept which can be supported by a CI system is documentation. You, of course, have to have documentation to explain your software in terms of specification, use cases, design, test, etc. And having this documentation in your repo is making it even easier to maintain it. For example, using Markdown format or equivalent. And the nice thing is with CI system, you can also include some more dynamic information badges. And in this case, you can have status of your pipeline. You can have also some index for the maintainability. You have also information about the test coverage. You can even combine it with a view on your test results. And this is, the CI systems can really help to collect and even generate in this information, making it even easier to document your code. So for the next concepts, maybe a short reminder on this workflow. So here we will talk more about the build and unit verification. So the bottom left of the infinity symbol. And obviously, speaking about build, obviously we can automate this. The nice thing is that since it's automated, it can be done really often. So any change which is made, can be checked for assembly or compilation, depending on your language and framework. You can then generate executable for the target system really often, and also, of course, checking the merges. Next to your build, you also want to have a unit verification. So unit verification, this is really all the things that can be used to verify the quality of your code. Can be code review, static analysis, functional tests, and the CI system can, of course, support the automation of all of those steps to have them executed for each change, each branch. Basically, anything you want to trigger a unit verification can be automated with a CI system. Another topic for the first part for the concepts is the artifacts. And actually, artifacts can be a lot of things. It can be executables, can be archives, can be test reports, libraries, packages, etc. And the thing is that with we're working using CI systems, you want to store them, you want to manage those artifacts to be able to reuse them at specific moments. You can use an integrated management system or a standalone system next to your CI tool. And the thing is that your CI system can automatically upload and download artifacts. It can interact with those systems so that it can serve itself to take what it needs to perform testing or deployment. Last part of the concept, and it is something that we actually explained in the previous webinar. It's container usage. Containers, can be really handy to have your tools and libraries within one environment. With one container, you can have your compiler, your system libraries, and so on. And for consistency and sharing, that's actually the one of the best ways to create this information. And using containers in your CI system, you can make sure that you have the exact same configuration for each job. You can check it locally. You can then use it in your CI system. For consistency and sharing, it's the ideal case. It can even go further. If you want to deploy an application, you can also put your application in a container. Then it can be deployed, and it can also be scaled up, meaning you may need at the beginning only one instance, but yeah, as you need more to serve more requests and so on, you can scale up, and those containers can just be instantiated multiple times. And a CI/CD system can make use of those containers, of course, to manage different steps of your work and making it always consistent and easy to share. Okay, that's for the first part, for the concepts. Now we can dig in to some more detailed demos and walk through those demos together. We chose to have two demos, one for embedded software and another one for web applications. So why two? Build and test are similar for any kind of software. Of course, yeah, different frameworks, languages, and so on, but it basically always comes down to building and testing. However, the deployment and monitoring is more commonly used for web applications. Of course, yeah, IoT also can make use of that, but it's not something that is used for all embedded systems, and therefore we wanted to have two separate demos for different parts. For the first part, for the embedded system applications, where we can explain the workflow for which can be applied for different devices. So you can here work on embedded controller for automotive, for some device to detect impacts, or even for Wi-Fi access point. Um, the workflow that we are going to go through now is quite similar in those cases. Again, a reminder is also for this first demo, we focus more on the dev part, so the left side of the infinity symbol, meaning that, yeah, mostly we'll talk about build and test. Here is in this first demo, we discuss about the typical build, test, and deploy flow. This is quite common. So the deploy, of course, is the last step. We will detail this even more for the web applications. But let's just say that the deploy in this case would be just to provide the executable, and we will not delve into the technologies that are being used. We will discuss more about the best practices for each step of this workflow. And the first best practice is to use to describe your job as part of your code, so the job as code principle. In this example, we use GitLab, and we describe the pipeline in a text file, in a YAML file, which you can see on the left. In this text file, which is stored next to your application code, we describe the different stages. We then describe the build, the different steps for the test, and the deployment. And the tool provides also generates also a graphical representation of your pipeline. In this case, you can see from left to right, build, test, and deploy with some steps in parallel. The advantage of using Java as code instead of the user interface is that you can have it next to your code. So meaning if you change something which impacts also the CI, you can do it all together, and it will be used as such by your CI tool. And it also avoids then I would say the difficult maintenance of graphical based pipelines. Here with a text file, you can perform some diff reviews, well, basically the same as for a piece of code. The second best practice here, use clean environment. What does it mean? It means that for each step, each job of your CI pipeline, you would use a clean environment, so like a new working copy from your repository. We do that for limiting the possibility of side effects, like dirty environments with some artifacts, some objects, some intermediate files lying around and maybe impacting testing or deployment. We also do that to improve the portability. In that sense that, yeah, we have different different steps. We could even think that all those steps are not executed on the same machine. Maybe we have I don't know, 5, 6, 10 runners available, and well, the system will just distribute the load to make it as fast as possible. And yeah, since everything is containerized and clean, well, we don't have an issue with that. Another best practice with CI systems, the fail fast principle is actually, when we mention this, it means that we want to notify the developers as fast as possible when something is wrong with the pipeline. In this example here, there was a commit push and the build is okay, but for some reason the tests fail. In that case, when the job fails, we stop the pipeline, we notify the developer, so it can well, get an email or chat message and well, work on the issue to fix it and restore the pipeline. Could be fixing the code, could be fixing the test, but the key here is to have a fast feedback loop in order to keep things working and checked at all times. Moving on to the next best practice is the build only once practice, meaning that if you have a pipeline with build, test, deploy, and many steps, you don't want to rebuild your application over and over. You just want to build it once, the first step, and then save the artifacts which are generated and promote them through the different steps. So you would save the executable of your build step and pass it to a test. Per test will be performed. When okay, the same artifact will be promoted for deployment. This limits the number of inconsistencies that arise when compiling and packaging. Another best practice, bit more difficult maybe to realize, but really powerful, is to use the CI/CD as the only way to deploy. Meaning that the CI/CD pipeline is the only mechanism which can promote code for production. Meaning no bypass, no way to override the system. The only thing which can deploy is the system itself. And why, while we could think about bypassing to go fast and fix a bug, doing so might also prevent some tests to happen, and actually we may have regression and having more bugs in the end. Of course, it requires some discipline and also a fast and reliable and stable pipeline to operate. But again, if keeping the CI/CD as the only way to deploy, you can be sure that yeah, everything is checked at all times, and that you limit the amount of regression and bugs that you introduce. And speaking about fast and reliable pipeline, it is also a good practice to keep an eye on that and to keep it fast and reliable. To do so, well, one needs to monitor the performance. In this case, we monitor the build time. So well, at the beginning, it works, no problem, some spikes, but we realize that it's actually not that fast compared to, for example, local builds or whatever. And so by monitoring the performance, we can detect anomalies and potentially also define some improvements. In this case, what we realized is that we had a lot of IOs, and by replacing a mechanical hard drive by an SSD, we dramatically decreased the required build time, and hence then making it even faster and so more useful to use for yeah, checking all the push, merge, and all the changes made in the code. Okay, that's the last best practice for the first demo. We can move on to the number 2, web application demo. In this case, it's a very simple application, which is just maintaining a list of users, but we will use this example to just describe the steps for deployment, orchestration, and monitoring. So the right side of the DevOps symbol, and in this case, the CD system is potentially using a lot of tools. We will just go through the overview of this part. So of course, here on the left side, you have your CI/CD system. Again, could be GitLab, could be Jenkins. But when moving on for the continuous deployment, we want to use, in this case, an orchestration tool with a cluster running our web application, and also a reverse proxy slash load balancer. To run those applications, we want to use secrets, and well, therefore we also would use another tool, in this case a vault. We also want to well, have a look at the health of these different services, and use a service discovery tool as part of the orchestration. And to complete all of this, we also want to use monitoring, monitor different things about application, about infrastructure. And the first thing we can say and actually repeat is to use containers for applications. So in this case, the concept is to use containers for different parts of your application. In this case, this application is composed of 3 elements. So the backend could be any type of language, in this case Python, Flask. The front end could be simple HTML, CSS, as this case could be a more complex application, and a database, in this case a MySQL database. The thing is that with a containerized approach, CD systems can really easily deploy and scale up containers, because well, everything is well isolated and contained in one element, and it's really easy to manipulate for these systems. And well, once you have containers, once you have, want to deploy them, you have also to select a good deployment strategy. There are a lot of strategies which exist. You can just think about recreating your application. So version B replacing version A when this one is terminated. You can also decide to ramp up. So having a version B slowly taking over version A by, yeah, for example, yeah, redirecting the traffic and so on. Can also be in a mixed approach where you gradually switch the traffic from A to B using a blue-green principle. Could also have a canary deployment, which in this example is the one we selected. The principle is to release to a subset of users before rolling out for everyone. And the last possibility is to use a shadow deployment. So both version A and version B, so the old and the previous release, are running together, and you direct the traffic in both versions, and you can actually check the response without disturbing the end users. You can just check it on a separate, I would say, environment, separate site, just to make sure it works before switching to another type of deployment. Some deployments would require some minor step. Some others could be completely automated. The key here is that actually a good CI/CD system can support all of these type of deployments, and you can even combine and have a hybrid approach to do so. Another thing here is then to use then orchestration. So again, orchestration with the principle for the Nomad cluster in this case. In, I'd say, this orchestration, we have different parts. I mentioned quickly, Vault is used for secret management. So for example, if you want to store secrets for your Docker registry or for your database user and login, it can be used. Your orchestration can then automatically fetch this information and inject this into your application, so that you do not have to share all the secrets with everyone, but it is there present for all. Can be also that you want to use console for service discovery and to actually have, let's say, the detection of new applications, new deployment, and triggering updates of your reverse proxy configuration. I mentioned here an example of about Nomad, but of course Kubernetes or other equivalent tools also work fine. And the key here is that, yeah, CD systems can interact with those orchestration systems. Moving on to the next part, monitoring. So in this case, we have monitoring with different tools. The monitoring here is more about application and application logs. In this example, we have Docker logs. We use FileBeat to scrape those logs and to ship them to an Elastic database. And from this Elastic database, we have a visualization tool like Kibana to actually show you what happens. One example here is to just count the number of access to your web application, and yeah, you can see then, well, number of access in the timeline. So you can also zoom in, zoom out. You can select some specific timeline, and you can combine with all kind of aspects. So you could count the number of errors or the number of OK access. You could also dig into the logs for more detailed search of information, like you would do, for example, in the console log. You can search and filter, and again, yeah, it makes it more efficient to do so, to collect information in one place and be able to browse through it. This case, it's very simple. Could think about a lot of different, more complex ways of using this. One of the other things we can do in monitoring as part of your CD system is to monitor the performance of your application. I mentioned earlier the monitoring of the performance of your pipeline, but of course you can do the same with your application, meaning that you can collect information about the duration of each transaction, the request per minute. So in this case, in this example, we use a specific application module, APM from Elastic, and this provides information which we can quite directly visualize. And again, to collect feedback, to monitor correct operation, that can be really powerful. For example, if you have a lot of traffic, you realize that maybe one instance or two instances are not enough, you can act on that. You have the data to decide it. Okay, we are moving to the next part and reaching almost the end of this presentation. So next part is infrastructure monitoring. So we spoke about monitoring CI pipeline, application. Of course, we, as part of the CD system, we should also monitor the infrastructure. So the computers, the virtual machines running your cluster and your application. So in this case, yeah, we have different tools to monitor different things. Could be exporting information about your physical machine, your virtual machine. Can also be specifically for your Docker containers. Can also be to check on your web application operation, so with response time and availability. And all of this can be collected and also used to trigger some alerts. So in that example, we use Prometheus and Grafana. And the idea is also, when something is wrong, to send an email or a chat message, for example, in Teams, could be Slack, could be a lot of things. And to illustrate that, just to couple of dashboards. On the top left, you can see a dashboard monitoring websites. So check if they are online, if they respond well. Can dig into some more details with graphs. We are showing the information over time. The same for system resources or Docker containers. As I mentioned, alerting, just well, here an example of what it can mean. So just a chat message saying, yeah, there's an alert. And then afterwards that this is back online, meaning that, yeah, you have a way to collect and show information. This is in practice done quite easily with webhooks. So there are a lot of different possibilities to connect everything together. Okay, and that brings me to the last part, the conclusion. So what can we actually highlight from this? So CI/CD main facts. Well, they can actually, those systems can help to automate all that can be automated. So again, build, test, packaging, deployment, monitoring, alerting, anything that can be automated should be automated, whether you have some code generation with some specific tool or just I would say usual build. All of this which can be automated should be. We also with CI/CD systems can have a good overview of the ongoing work. For example, a team lead or a project manager could just have a look to the pipeline, check the status for a specific branch before release, check the test status, go in more details for maybe some specific test cases and performance testing. And there are a lot of different solutions which exist. So meaning that it's quite easy to customize to your specific needs. You can maybe decide to go with a specific CI tool. Maybe you go with Jenkins and you want to use some other artifact management system and some monitor tool. Or on the contrary, you prefer to have an all-in-one solution and to do it all from there, like for Azure DevOps, for example. And it is all possible. There are a lot of different solutions. It's always possible to customize it your way. Last but not least, you don't have to deploy everything at once. It can be and it should be deployed in an iterative way. For example, you can start having a CI system to just build one branch. Then maybe you want to include your merge requests there. You add some tests, some verification, packaging, and so on and so on. The key here is to avoid big bang integration of everything to at the same time. So why do all of this? Actually, well, key benefits which would speak to all of us is first to free up development time. Having a set of machines to do recurring tasks for you means that you are more available to spend time on features, bug fixing, real development work. It also helps to improve the code quality, to more testing because it's automated, meaning more ways to see if everything works well or if you have regression. Also with CI/CD, you have faster feedback, so you can see things before they even get to production. But let's say you get to production and you monitor and you still find something, you can also have a way to detect issues before your end users complain. Also, another benefit is to have more frequent releases. You release in smaller batches, but faster, meaning that you also have the possibility to deploy new features faster. And doing so, collect more feedback, improve quality, and so on. Last but not least, cost reduction. Well, let's say you have this constraint because you automate build test, you have less human labor needed to do those things, and well, focusing more on development rather than on those recurring operations. And that's actually it for me for the presentation. Thanks for your attention. I think we can now move on to the Q&A part. I will stop sharing my screen and maybe ask Max if there are some questions. If Max is there.
Yeah, I'm here. Sorry.
All right.
Yeah, there was a very interesting presentation. My cameras don't seem to be responding right now.
Yeah,
so
that's
I
why
don't
you're
know.
clicking. Okay.
Yeah.
Yeah, on my side, it seems to be working. However, it's strange. I think the spotlight thing, the highlighting of the speakers, maybe not working well. But anyway, so are there questions?
There are actually a few questions in the Q&A section. So we will see how much we can handle within the limited time we are given. In advance, I'm not an onomatologist, so if I mispronounce any names, excuse me. So the first question is from Eunice. Out of the vast set of tools available, what is your favorite stack of tools for CI/CD and why? Actually, for my experience, Concourse and CMake, SonarCube, Docker are my favorite tools. Also Jenkins because I have most experience with it. So I don't know, Denis, what is your
for me,
opinion on it?
well, it's a good question. Thanks, Eunice. Over time, it has changed. So I would say at the very beginning, I liked Jenkins a lot because quite easy to set up, lots of plugins, tons of plugins. Also efficient way to configure your pipeline. Back in the day, it was easier to make it using the graphical interface for the team. Nice thing, and still good tool, but nowadays I prefer a lot more GitLab. Why? Yeah, it's all integrated, so it's good thing and a bad thing. But for my use cases for developing embedded systems or web applications or combination of both, it's I find it a lot more convenient. You have one place where you have your users, you can configure access, you can enable features like a registry, a wiki, you have the pipelines, you can also collect information with badges and so on. And yeah, since it's using a containerized approach, it's very convenient to set up a cluster with one server and many runners. You can even scale up and down on this. So right now, I would say GitLab. I'm not saying it will be like this forever, but at least right now, it is my favorite tools, and I can still also link it with other tools if needed. We did the exercise to link it to Jenkins, to use a Nexus repo manager, and so on. You can also collect the built-in mechanism to collect metrics, which you can also export to some other tools. So voilà, that's, I would say, for now, this tool.
Okay, thank you for your answer. Then there are two more questions from Eunice. He's very active in the Q&A section.
Yeah,
Let's maybe take them together because I think
yeah.
they are a little bit related. So the first one is, um, do you expect that it's more required to use a dedicated external DevOps team, or do you think that the project developers can set up the toolchains themselves? And on top of that, do you think that it will be an expected skill for every software developer to become a DevOps developer?
Okay, so it's a good question. Um, to answer on the first one, so should the developer team or a dedicated DevOps team set up those tools? I would say ideally both. To explain, ideally you would have a DevOps team to set up those tools, and I would say different yeah, integration and cooperation between the different tools for the developers. But ideally, the developers, different teams, would create their own instance of the DevOps system. So, for example, if you have a DevOps team setting up GitLab plus Nexus plus Grafana, Elk, and so on, maybe you have like 5, 10 different teams for different projects. The best way would be that each team can actually self-service or instantiate the CI/CD and use those tools in their own isolated environment and way of working. They may have different pipelines. They may want to tweak some settings, and that's actually where then both need to work together, because yeah, the DevOps team should set up what is needed for everyone, but then each development team should be able also to understand what's in there and tune it for specific needs in order to be efficient. So the key here is to making it efficient and useful for your own case. So I'm not such a believer of like one big CI system workflow for everyone in a big company, but it's much better to have some frame and that you can instantiate. It's even more important if you use the cloud, where yeah, you may want to instantiate only when you need, and maybe you also have different I would say usage, so the scaling will not be the same. And the second question, so is it expected to be skilled in DevOps for development engineers? I would say yes, of course. Well, if not to set up everything, because that's indeed a different job. It is more related to infrastructure, networking, and so on at some point. So, but developers should know how it works. So they should know, okay, well, the CI is there. I can automate this and this and this. Okay, I need to know the best practices, the main principles to, use artifacts to limit. I would say the number of redundant steps, etc. So I would say in the usage, yes, the developers they need to know how DevOps and CI/CD systems work. But yeah, it should be still up to I would say different people to set it up, because yeah, it's typically other skills which can differ quite a lot.
Okay, we got an explanation about who is going to set up the CI/CD system. And now there is a question from Quinton,
Hmm.
more related to when should you set up your CI/CD system.
Yeah.
He imagines that it's not a good idea to decide to set up the CI/CD system if you don't even know which tool chain you want to use. So his question is when.
When? So yeah, maybe I will rephrase a bit the question, and Quinten can react if it's not clear. But I would distinguish, yeah, I would say the CI/CD and the workflow from the specific tool chain that you want to use. So in my opinion, even if you don't know which tool chain you want to use in the end, you could still benefit of the CI/CD system from the start. So I mean, if you start developing even a proof of concept, you, I don't know, for example, you develop on an ARM device, and you want to get some test on connectivity or whatever. You first choose one tool chain, but you can already start using the CI/CD from the very beginning to automate the build, some tests, maybe not very, I would say, complete tests, but at least some tests, also static analysis and packaging, meaning that you would build executable files that you can directly use out of this. If later on you decide to change the tool chain, so compiler or other tools, well, there is no restriction in doing so. It's would have been done anyway with or without CI/CD. So why not use a CI system to automate already what can be automated? Now, if in terms of tool chain, Quinten means more like the CI/CD tools. Um, well, yes and no, it depends. I mean, you can also start, like I mentioned, with a all-in-one solution such as GitLab, and it already does a lot of things as long as you can work with containers, of course. But even if you cannot, you can find a way. And if you, for example, have a feature that you really cannot have in GitLab, but you really need, you could also just port the CI/CD workflow to another tool. Can do it in parallel. Again, it's also to be seen as a development on its own. So you can decide on the deployment strategy, whether you do it in the shadow or you have a canary deployment for your new CI/CD, which, for example, could use Concourse or Drone, whatever. So yeah, to make it simple, yes, it's a better idea to start from to use a CI/CD from the start, because yeah, why wait to automate what can be done?
Okay, thank you. There is a question from Bart de Vos.
Hmm.
Um, it's a little bit a long one, but I try to summarize if I
Hmm.
understand well what he's meaning.
Yeah,
So he has a question regarding different builds.
yeah.
So there is a suggestion to make one build.
Hmm.
Probably in the examples we made a suggestion to make
Yeah,
one build,
yeah.
but I expect that CI/CD is the perfect tool to provide three builds. For
Hmm.
example, he says a debug, a release build, and also a coverage build.
Hmm.
So his question then is, would you suggest to split up this in three different CI/CD jobs or consider it as one build job?
It's a good question. The answer is, well, it actually is more up to you. I see where this is coming from. So indeed, yeah, you may want to have a debug release with debug symbols and something not optimized, but you can actually use this artifact for using with a debugger, an emulator, or something. A release binary for optimized version which runs faster and so on, and a coverage a binary with instrumentation to check out coverage. And it really depends. I mean, referring to this view on the repository and the different branches and so on, maybe you want for feature branches, maybe you want all of these, maybe you want debug, release, and coverage. So you could perfectly have a build step with three jobs in parallel because you want them all the time. But maybe when you promote your code to testing and even release, well, you want to remove the debug and coverage builds because you won't use them, so you don't need them anymore. It has been tested. You just need the release binary. And in this case, yeah, it's perfectly possible to decide, for example, based on the branch name, yeah, if it's feature slash whatever, I build the three, I would say, different binaries. If I see that I am on the master or release branch slash whatever, then I just build for release. So it's a matter of optimization. It's again, the principle to build only once is there to make sure that you reuse those things. I would even go further and saying, yeah, build only what you need, because yeah, if you build coverage for release, but you're actually never going to use the coverage binary for this, yeah, better to just skip it and save some time and keep it fast in the pipeline.
Okay, thanks for
Yeah,
your answer.
I hope
Uh,
it's answering the question. Yeah.
there is another follow-up question from Bart de Vos
Hmm.
in a similar regard. So he asks if it's possible to continue with the pipeline if one of the, for example, builds failed. For example,
Hmm.
the release build failed. Is it
Hmm.
possible to continue the pipeline to
Yeah.
still build the debug version to get
Hmm.
the debugged binary and pinpoint the issue, for
Yeah.
example, the debug version?
Yeah, sure. Um, yes, again, it's some decision that you have to make. In these examples, I did not detail, but we kept the default principle, which is if you have an error, it stops. For a lot of cases, it's what you want. You want to stop as soon as you detect something bad, but maybe you just want to have a warning. So you may want to continue the pipeline, stop later. For example, in this case, if you have a debug build which works, but not the release, you may want to still use this debug build to try it on a target and see if or target or the host to see what's going on and why it would potentially fail to build. And so it's possible. It's a matter of decision. Of course, yeah, that could be dangerous if you just put everything to warning level and you don't stop. It's like for compiling code. It's if you move the errors into warnings, you may expect also some incorrect behavior later in the process. But again, it can be done, and it can also be combined with decision based on, yeah, where do you build? Is it for a feature branch? Is it for hotfix, and so on and so on.
Yeah, so it's the developer can decide.
Yeah,
Maybe a last question to keep
yeah.
time, and it's one also from Eunice regarding the costs.
Hmm.
So, how do you tackle the stakeholders' resistance to CI/CD implementations in a project due to
Hmm.
the increased cost it brings? For example, if you need
Hmm.
to buy servers, cloud services, I don't know, development time to put into the setting of the pipelines.
Yeah.
So, how do you tackle that?
Well, then when you have some resistance from your team lead, manager, and so on, it's important to understand what is the issue. If the issue is cost, like Denis is mentioning here, well, you have to compare it to the cost of not having the CI/CD in place. Um, for example, if you have an application you're expected to release every 2 weeks, of course, that means that you even need to have like intermediate release faster than this. Yeah, how much does it cost to actually manage this manually? But let's say you're in a small team, but you have to go fast. You don't have the resources, the infrastructure to do it on premises and so on. You have to use the cloud. So what's the cost of a cloud service, which could be maybe, I don't know, 100 euros per month? What is this cost compared to the time you lose actually doing this work manually? And what is this cost also in terms of quality, which you don't have because, yeah, you don't automate the test and so on. That is, I would say, the kind of discussion that you should have with the stakeholders, because yeah, if cost is an issue, it actually costs more. Typically, not it does cost more to not do it, at least in the medium and long term.
Thank you for the answer, and I think we will wrap up here.
Hmm.
So check the Entech website in 2 days for the video and also for future webinars. Eh? Have any closing remarks, Denis?
No, well, I would say, well, thanks for thanks to everyone for the attending this webinar. It is also something that we will do still in year 2021 with a lot of other topics. So it's also available on NTech. If you do have still some questions, you can contact us. So ntech@nardis-group.com, or if you know our contact information, yeah, feel free to send us an email or to call. But yeah, indeed, let's keep the time. Thanks to everyone. Thanks for the well, introduction and conclusion, Max.